Honda announced to stop selling pure fuel vehicles in Europe in 2022. Volvo declared to become a brand of pure electric vehicle in 2030. Ford also targets to stop selling fuel vehicles in Europe in 2030. When leading car manufacturers announced to make the switch to EVs in the coming 10 years, demands for car chips bottomed out and skyrocketed in Q4 2020, leading to a severe shortage of semiconductors. This is undoubtedly a rare opportunity for Taiwan semiconductor manufacturers who want to enter the automotive market. Electronics are bound to undergo a series of rigorous reliability tests in order to enter automotive industry. So, what should we do to improve product reliability and become part of the supply chains for EV manufacturers? Hello everyone, welcome back to the iST Ease Your Pen. I'm Laura, your hostess today. When automotive manufacturers would like to develop a product or function, they define system function, subsystem function, the electronic control unit to employ, and semiconductor components to be used from top to down. On the contrary, validating requirement compliance happens in reverse order. Assuring quality from the very beginning is the only way to make highly reliable products, as unstable foundation can easily collapse. Without following the V-curve, it would be difficult to pinpoint the causes of product failure. Is it caused by poor product quality in the previous level, a process issue, or poor design? Please subscribe to our channel. We will continue to share our first-hand observation of the semiconductor industry with you. We will divide this V-curve into 5 steps and share our practical experiences to help you learn about the key points of international automotive specifications. Step 1. Regarding the reliability of automotive ICs, passing the verification of AEC-Q standard published by the AEC is the very first entrance ticket we must obtain. Due to the safety concerns from international car makers, AEC-Q 100 has been listed as a mandatory requirement for ICs. Also, because of end customers' climbing interest in AEC-Q 101 and AEC-Q 200, these two standards may also become mandatory in the future. We suggest that manufacturers take actions in advance. In addition, in terms of the zero defect goal of electronic products set by international vehicle makers, the AEC has issued AEC-Q 004. It aims to implement the industry's best processes, tools, and defect screening methods in different stages of the component lifecycle. It targets to lower the defect rate to 1 part per billion. About the introduction of AEC-Q 004, please refer to our previous video. We can replace a failed component on a PCBA through rework, but it is not realistic to replace the PCB of a PCBA by removing all the components on it. With the rise of the automotive electronics market, IPC published IPC 6012DA in 2016, which includes PCB qualification standards and acceptance criteria. This standard is now an important reference for vehicle makers and Tier 1 in PCB reliability verification. Step 3. Board level reliability. BLR tests are the most commonly used methods to verify solder joint reliability after an IC component is mounted on a PCB. BLR tests have been routine test items for handheld devices. As more and more IC components are used in cars, the complexity of automotive electronic system increases, and therefore, BLR tests are becoming important for automotive qualification. Tier 1 module manufacturers including Bosch, Continental, and TRW even created their own test standards for BLR tests. The AEC also published AEC-Q 104 in 2018 to clearly define the test items of BLR. However, only a few BLR test items are included in AEC-Q 104, and this standard applies specifically for multi-chip modules. Other common packages are excluded from the scope, which is not completely in accordance with the specifications of Tier 1. AEC-Q 104 is considered a big step in general automotive standard for board-level reliability. Considering the booming of the automotive market this year, we may look forward to the update of AEC-Q 104 by the AEC. Here we also summarize the top 5 failure causes of solder joint in automotive BOR tests. Number 1. Solder joint size and array. Number 2. Solder joint alloy composition. Number 3. PCB design and material selection. Number 4. Reflow temperature and flux residue. Number 5. Underfill application. Among them, the most common problem is warpage, since automotive chips are likely to operate in very high temperatures. However, the materials in the IC come with different thermal expansion coefficients, resulting in different warpage degree, which, in return, may pull and press solder joints and break them. Please refer to our previous video for the solution to the warpage problem. Due to the rise of environmental awareness, the EU started to implement rules in July 2006. It restricts the lead content to go below 1000 ppm in electronic products. The transition from tin lead to lead-free solder paste changes the melting point from 183 to 217 Celsius degrees, which in return results in hardening and brittle solder joints. Such solder joints could lead to poor fatigue resistance as well as tin whiskers. This greatly increases the difficulty of lead-free process. Compared with consumer electronics, automotive electronics adopted lead-free process in a slower pace because of its high reliability demands. It was not until the revision of AEC-Q 100 in 2014 that a verification requirement for lead-free testing was added by the AEC. Thanks to lessons learned in implementing a lead-free process for consumer electronic products, manufacturers are more experienced in managing the challenges of adopting lead-free process in automotive electronics. System module qualification standards can roughly be divided into 2 types. The first one is the International Automotive Standards, ISO 16750, is the most widely used qualification standard in the industry. It contains 4 groups of tests, including electrical, mechanical, environmental, and chemical verification. The second one is the specifications published by car makers or Tier 1. The suppliers must pass the specs before they are recognized to become part of the supply chains. Based on iST's actual experiences in contact with the automotive supply chain, to survive in the automotive industry for a long time, it is necessary to break away from the existing thinking of consumer electronics. There is no room for compromise on quality and reliability, and price is the last consideration. The verification period for the introduction of new products may take 3 to 5 years. It may even be as long as 20 years for the after-sales maintenance and preparation of parts. To quote Toyota's president, "After making a vehicle, I would like them to be prepared to deal with customers and various changes for some 40 years. To enter the automotive industry, business owners must be more patient and determined." In today's video, we only share a few key points with you, and please click the link below for detailed information. If you have inquiries in automotive electronics verification, feel free to contact us. So that's a wrap for today. Bye! iST is your pen, first-hand industry observation. If you like this video, please press like. If you want to see more, please subscribe to our channel and turn on the notification bell so you won't miss any of our future videos.